The area of a playground is 247 square yards. The width of the playground is 6 yards longer than its length. Find the length and width of the playground. So when faced with a problem like this, your first and best thing you can do should always be to draw a picture. Pictures help us work things out immensely because that's things you don't have to store in your brain. You can store them on paper. That frees your brain up to do other things. So let's list what we know about this playground. We know its area is 247 square yards. And let's find out what we know about its length and width. Remember, it doesn't matter which one you call length and which one you call width. I'm going to call this length and I'm going to call this width. You could reverse that. It really doesn't matter. We know the width of the playground is 6 yards longer than its length. Yeah, that's great, but how long is it? Find the length and width of the playground. They tell us nothing about length. So what I'm going to do is I'm going to say that length, since we don't know anything about it and it could be anything, I'm going to call it x. And so now I have a length of x. My width is 6 yards longer than its length. So to find the width, what I do is I take the length and I add 6 yards to it. So my width is x plus 6. My length is x. And you'll remember that the area of a rectangle is found by taking length times width. Well, my area is 247. My length is x. And my width is x plus 6. I can multiply this out. And I would get x squared plus 6x. And now I've got a quadratic with its c term over here as opposed to here. And all I need to do is solve that quadratic. And I can use just about any of the techniques that we've learned in this module. Now I can't use taking a square root because we have both an x squared and an x term. But I can do this by completing the square, by factoring, by using the quadratic formula. Any of those will work. Given that it's in this form right here, completing the square just kind of makes sense. It's already set up to do that. So I take half of this term, which is 6, or half of 6, which is 3, square it, and that's 9. So I'm going to add 9 there. If I add 9 there, I have to add 9 there as well. 247 plus 9 would give me 256. And now this over here is a perfect square. That's going to be the square root of this term. And then half of this, so that would be plus 3 squared. Let's take the square root of both sides. And we can find that the square root of 256 is going to be 16. So I say 16 equals x plus 3, but we have to be careful because that's positive or negative 16. So now I can set up two problems. I know that it could be positive 16 equals x plus 3, or it could be negative 16 equals x plus 3. Let's solve them. So here I would get that x equals 13. Over here I would get that x is equal to negative 19. Now so far we've worked out we've got two solutions and we've said, hey great, we're supposed to get two solutions, it's a quadratic, but our two solutions don't make sense right here. This is a playground, this is an actual thing, this exists, this is not just something that's happening in our head. And so this has an actual length, which is a distance. Like if you were to walk along that side of the playground, that's how far you'd be walking. And so look at our two solutions. Is it possible to walk 13 yards? Absolutely. Is it possible to walk negative 9? Hey, that doesn't work. You can't have a negative distance. So this is an extraneous solution. It's a solution that makes sense mathematically, but not through common sense. So what happens is we are going to get rid of that, and our solution is that the length is going to be 13, and our width is going to be 13 plus 6, which would be 19. So there we found the length and width of our playground.